a copy of the link. That would be really helpful. And I can most helpful. So just as a bit of primer while we're setting this up, the goal of this study is for, I have, 6 or 7 patients right now and debate over which ones are usable right now. I'm just running them with all of them and then we can decide later if I decide.
Could you guys move the mic a little bit closer to the...
Yeah, sorry, I'm not talking super loud today. Not usually a problem I have. Okay. So I should be here. So we're comparing for a number of conditions across a number of subjects. So there are 3 conditions that we're really interested in. Let me share my screen. And then that works for the, so, and we're testing a number of hypotheses around that. So the 3 conditions we're really interested in are repeating the same phoneme, same syllable, so it's just the same word repeated, the same phoneme, different syllables, so it's just scrambled, so like gad and dag, or some such thing, or all different. And so we're looking for whether or not there's repetition suppression, and here are the various hypotheses. So what had previously been done in this study was just ROI-based analyses for every ROI they could think of, and then selecting ones that they thought looked like one of the things. So I think that that's maybe not the most systematic thing that we could be doing. And so I would like to hopefully, unless we want to decide on a specific ROI going forward, I would like the whole brain analyses just sort of comparing those 3 things, which I've run comparing 3 things, but it's just what shows up is just areas that are significantly different in all 3 of those. I think it's not easy to understand, and it isn't showing a ton of things.
And we have for that sort of the ROI based pattern analysis, we have a whole set of scripts to run that. So you're not just looking saying like this looks right. It's actually there's a statistical test to determine if it fits that pattern or not, and otherwise tosses it away. So
I'm more concerned about the fact that it's just run with every ROI. Is that?
Well, typically what we do is you'd start out, you'd have some hypotheses. So for something like this, you'd say, well, it's going to be. We think that it's going to have to do with left inferior frontal and ventral premotor and maybe SMA and pre-SMA. We'll have something, so you start with that. But for this study is a little bit different because this is the ECOG.
Yes.
ECOG subjects where I think part of it's just looking at where they're active for speech, right? This is a little bit more exploratory. I think Jen just adapted this protocol to use with these subjects. So, I don't know, Alfonso, we actually, this came up last meeting. We could talk about trying to fit in the pattern analysis into FL. I don't know if you think that's something that we should do, or if we should just have it be this other, you step outside the normal pipeline to do this.
No, that's a good point. We should probably mix it. I mean, it's currently not there yet. So we have this whole model-based statistics kind of framework to do this type of comparisons, and those kind of take into account all of those issues. Basically, the fact that you have multiple conditions to look at that you want to compare to create these models, and the fact that you have a lot of regions that you are exploring, kind of like the analysis, and it does a randomization test to kind of like get a sense of the patterns that you get and how similar they look to the patterns that you expected, whether that is significant or not, taking into account all of those things, that the number of ROIs that you have and all of that. And currently that basically has to be kind of like taking from the results. I think I will have to look at the scripts status right now, but I think probably you can just make it run or adapt it relatively easy to make it run with the files, the ROI.mat files that are created by our ROI level analysis. But I'm not totally sure about that. But I think it would be a good idea to have that basically merge into our FL pipeline, just to have like an additional set of ROI level analysis which perform this type of model-based statistics.
If I could jump in here.
Yeah.
So we'd actually run this. So there is this whole set of scripts that does the model-based statistics for the other repetition suppression studies that we've done. The one thing about this was that because we've been, I guess you can do it at the level of the second level, I guess that's what you want. But previously we've just been looking at these individuals, like individually, where it was more difficult to estimate, matching the patterns statistically because you don't have the same amount of variance, but I'm sure it can be done if you want to do this just in the second level analysis.
Right. The original setup of the analysis was actually to be used as a second level type of analysis, but we kind of like adapted it back to be able to run it also on individual subjects. But the original kind of setup is all based on pairwise statistics. So basically, you have this second level analysis, which are a number of t-tests basically comparing two conditions, and you do that for every pair of conditions. And then you compare the results of all of those pairwise tests to your hypothesized results for that. So basically, if you have a model of something like a staircase type of activation across your four conditions, then that basically implies that when you do the comparison between the second and the first, you should have higher activation in the second compared to the first, and the same thing when you do the third to the second. So basically, every model that you specify implicitly defines a set of results that you would expect to see across all of these pairwise comparisons across the second level t-test that you are performing across conditions. And then from those statistics, the actual results and the hypothesized models and the number of regions and the number of conditions and all that, the scripts actually run some permutation or randomization analysis. I think this work Monte Carlo actually simulations to get a level of significance of those results that you're getting. But yes, the original analysis were basically for second level analysis, so that should be relatively easy to adapt to the thing that we have on the FL pipeline.
Okay.
So what we can think about, like how we might adapt these for what we want. I guess for this study, I don't know really what the goal was with the fMRI, besides looking at what areas are more active in speech, like what are the areas that are active in speech. So presumably we would like to look at those individual.
So we already have individual speech minus baseline results for all of the subjects, and most of them correspond pretty well with Jen's. There's one or two that they still look speechy, but they look a little different, and that's probably just missing timing information and slightly shifted time windows. But they all look like, except for one that had sort of serious other problems, they all look speech-like and they all match Jen's. So that speech minus baseline, we're good. But in terms of individual tasks, it does raise a lot of questions on how to best tackle this. And I would have tackled this in an individual meeting, but I thought doing the group, we talked about in a previous tutorial how people might be interested in comparisons when you have more than two tasks you're comparing. Yeah. And I just thought that might be an interesting thing to other people, but if it's not,
No, definitely. This is a very good data set to actually talk about that, how to specify the contrast. So, I mean, beyond, I think the point for this meeting might be that beyond the model-based statistics type of framework that we have, and which we can just talk briefly about whether we want to actually incorporate into FL or not, and things like that. I think this is a very good example to think about what type of questions would you want to ask to this data, just from the standard type of second-level analysis that we've been run so far, and how to actually specify those contrasts, because that is kind of tricky with so many conditions. You're right.
Because I started off just comparing two conditions at a time, but then of course that's not corrected if you just say like these two and these two and these two. That's you need some sort of statistical correction. You can't just, I feel like that was the second level analysis version of just running a series of t-tests.
Right.
And so
given what we have here, that's the only way you would be able to do it.
Yeah.
Directly. You could do something.
Well, then is there some way to correct then?
Well, let's see, because I also, for your study, mass rate study, this would be kind of interesting too, because if you think about the way you have it written up now, it's sort of like you have like, well, there's this one where you're not really all that focused on how accurate it is. Well, there's the normal one, where you're just whatever it is. There's one where you're really focused on how accurate it is, and one where you're not. It's more speed. So you could think of that as sort of like a parameterization of some controller, and it would something like this, like being able to look at, okay, well, which one is there an area that actually where the activation level matches that some level of that control mechanism. So I think that would be handy to have in there. But maybe we could, I don't know. I guess Alfonso, if we want to finish up, I think all the everything else, and maybe consider like adding that in, or at least having access to the scripts that we've used outside of it. But I don't know, I guess what do you think we should for today? I mean, for one, it would be kind of interesting to look at the results are, but is there something that we can do, Alfonso, to kind of get at these questions the way it's set up now, or?
Right, we should be able to just define a few second-level analysis, and just for practice purposes, I mean, whether we actually want to use this for our papers or is another question, but just for practice, I think it would be a good idea to go over this analysis and just look at these designs and think about the questions that we want to ask and how to specify the second-level analysis. I think just for practice, do you think that would be useful?
Yeah.
Okay.
I don't want to be the one pushing analysis on people that they don't want. That's very rude, but...
And I think it's also just important to remember that we've dealt with these specific questions before, and that's why this other model-based software was developed in order to account for all of these things.
Right, exactly. So the way that we actually address it now, basically with this today, basically with these examples, is going to be somehow limited, and that limitation is basically what motivates us to actually create these other scripts that actually deal with that in a more rigorous way. But let's just do the limited way today, just for practice purposes, and because I think it's a good practice. What do you say?
Sounds good.
Okay, so this particular contrast that you are showing us, this is trying to do what exactly?
Sorry, what?
So this particular configuration file that you are showing us here for the I see that you have something strange here going with a two contrast.
This is what I refer to as the kitchen sink contrast, where it was just, I pulled this one up just because it has all of the conditions visible, so we can decide where to go from there. But this doesn't show anything sensible or useful when you actually run it, which I think could have been anticipated from the way it was set up.
So here, were you trying to basically do an ANOVA type thing where you're looking?
That was my original. I quickly gave up and went to like essentially a series of t-tests, which worked very well. They have very pretty plots, but they're not corrected. So yes, so this was essentially me attempting an ANOVA, which didn't.
Right, but why did you try the 6 contrasts instead of the 3 contrasts? So basically you have 3 contrasts, right? That are the main things that you get from each analysis.
Yeah, because I was concerned that that it wouldn't be two-tailed if I only had the 3.
Oh, I see what you mean. So right, so you're I see. So the last 3 contrasts are kind of like the other side of the first 3 contrasts, right?
Yeah.
Right, for an F-test, you don't care about that. So basically an F-test, you create like a three-dimensional vector for every voxel, right? You have a three-dimensional vector that tells you the values for every three contrasts, and you're just testing whether that vector has a norm of approximately 0 or not. So basically, is it a large vector or not? It doesn't care about the actual direction of the vector itself. So basically, this contrast, I would change it to only specify the first 3 lines after the contrast names, and then change the contrast within to just be 1 0 0 0 1 0 0 0 1. Yeah. And why do you have only 7 subjects in this study, or this is for some reason?
Yeah, it's a small study.
Okay, so then the lack of results could be because, I mean, this F contrast is going to have very few degrees of freedom to actually run only just 7 subjects, because
yes, which I'm aware of, but that doesn't mean I'm going to stop doing things.
Sure. Okay. But this is basically the way that you will run it. Basically, this tells you whether there are any. It's going to show you those regions that have any type of response in either of those 3 conditions. So, is there any? So, if a voxel shows differential activation in any of the 3 conditions compared to baseline, it should show up in these results.
So, how is this going to be different than the speech minus baseline?
Right, because the speech minus baseline would be like an average of the 3 conditions, and instead of looking at whether any of the conditions show activation, you look at the average activation across all of them, and then you are testing whether that is actually 0 or not. So, okay. So if the activation, I don't know, is positive in one condition and is negative in another condition, say that compared to baseline you get a positive activation in the same phoneme, same syllable, but you get like less activation in the same phoneme, different syllable. Then when you take the average of the 3 conditions, that kind of like positive with negative is going to cancel out, and you're not going to see anything in that particular voxel because it's not showing an average effect across the 3 conditions. But even though it's showing some effect in one condition and a different effect in the other condition. Do you see what I mean?
Okay, yeah, that seems like you could definitely get more information from this then.
Right, it's like a different way of, you try not to collapse or to specify which sort of across conditions type of merging you are hypothesizing. This doesn't make any assumptions about whether how the 3 conditions are going to be related or not. It might be that the activation is only in one condition, and maybe the activation is the opposite sign in one condition versus the other. It might be the activation is actually on all of the conditions. It doesn't care. It's just looking at whether there's an activation in any of the 3 conditions. But because you're doing that, it's also requiring a little bit more power. So in this particular analysis where you have only 7 subjects, you're going to have 4 degrees of freedom. So that's going to be really, really low. So it's like we're going to have to lower every threshold to be able to see anything here.
Ultimately, for this study, the idea was really to focus on first level, individual activation patterns, and maybe use those to determine where we're going to be searching for which electrodes we're going to be looking at, and that sort of thing. But so all second level like group analysis here, it'll be cool if something pops up, but with 7 subjects.
Yeah, I also was under the perhaps wild hope that we would at some point, if we give interesting results at some point, we would get more subjects, and then having the group analysis ready would be, I thought, important.
Definitely, and this, even though you might not have the power, it might be you may still get some indicative results of some interesting patterns that are showing up. So that might also give you an excuse to go and get more subjects to elucidate whether that is actually the case or it's just some random pattern.
So we're sort of working less towards publication and more towards Dr. Greenlee, please give us more subjects. Look, we found something.
Right. Okay, so this will be the less powerful but more generic way of looking at where any region that shows any type of response across any of the 3 conditions. This is kind of like the more like a omnibus type of test. Is there anything, it's going to give you regions that are significant if anything interesting is happening there in any of the conditions. So that's also a typical, if we have more subjects, but this is also another way that people sometimes use when you have this type of ANOVA framework to focus. Then you get like some clusters in this analysis, and then you just focus on those clusters, and you know that there is something happening in there that might be interesting. And it's a way to reduce the entire set of analysis, the whole brain type of multiple comparisons to a reduced set of interesting regions. Okay. So could you display again the model, the graph display where you were specifying type of like the model assumptions. What if this region
Oh.
was going to be something like this? So
Sorry, it's kind of small. So
no, perfect. Okay, so you could try to get at some of these questions. Do you have any guess as to how would you test if you are interested in looking at which regions actually are phonemic regions, and how would you test that like statistically if you only care about that particular pattern, for example?
So phoneme specific regions or just regions that are active during phoneme? Because I could just do, you know, a second level just on the phoneme group if I was interested in regions that were just active in the phonemes.
Right. No, I meant like so. Well, explain to me then, what do you mean by these four type of constructs? Basically, the phoneme construct that has a response of 1, 1, 2 is a region that is expected to be specific to only phoneme. It's going to differentiate between different phonemes.
Oh, yeah, there's phoneme specific suppression. That it doesn't matter the order; it's at the phoneme level, and so if they're all different, you won't see that repetition suppression.
Right, exactly. And the syllable is going to be some region that responds to like encodes syllable information, but it doesn't care about the individual phonemes, right? So
yes.
Okay. So how would you test whether some region is like a phoneme specific type of region, is encoding phoneme information and not syllable information? So basically, whether it does have that pattern that you expect.
I guess you would pool contrast 2 and contrast 3 and compare it to contrast 4.
2, 3, 4 are
the same phoneme, same syllable, same phoneme, different syllable, and compare it to all different.
Right, exactly. I mean, that's a very good. You can compare the average of the same phoneme, same syllable, and same phoneme, different syllable compared to all diff, and check like a one-sided t-test to look at the differential activation. Well, do you expect the activation to be higher? Yes, right, because you are looking at repetition.
Yes.
Okay, so then you would look at like one-sided t-test for that, but that doesn't still rule out whether the same thing might happen in a syllable specific. So some region that actually comes out as significant in that result might also come out as significant for a region that actually responds specifically to syllables, because since we are aggregating across the first and second columns, basically, that average is going to be still perhaps lower to compare to the third, but that doesn't mean that they are like the same. So how would you discriminate between a phoneme specific and a syllable specific beyond the test that you just did?
I mean, you could, I don't know, besides comparing just the phoneme and the syllable by themselves, I don't know compared to the all different, because this is the three-way sort of ANOVA. I'm not sure how to do that in the FL pipeline.
Okay, and I mean, you could do it with a conjunction. Basically, you could test in a conjunction. You basically have two analyses, and then you look at the result, whether there are some regions that actually show something significant in both of the results together. So, for example, you could look at whether the average of the first and second conditions are compared. Well, the second and third contrasts are lower than the fourth contrast is one type of test, and then you look at the regions whether that compare the second contrast and the third contrast, and whether show difference activation between the two of them. And a region that shows a significant, that gives you like a significant result in the first test, and it doesn't give you a significant result in the second, basically it's telling you that something that is a region that looks like a phoneme region, because the activation in the fourth contrast is higher than the average of the deviation between the second and the third, and the difference between and it doesn't seem to be any significant difference between the second and the third contrast. Does that make sense?
Yes.
So you could do that in FL pipeline. You would do that by running the two analyses separately, and then you go to like SPM when you display the results explorer and select a conjunction of the two analyses, and you can actually run a conjunction of the two. And you could actually do that. Yeah, I mean, there are several ways. You might actually do it. Don't need to run them, both of them, because they are going to have the same contrast, each of them, right? I mean, there are a couple of ways, but the simplest way is to do two analyses, one and then run a conjunction of the two analyses. A conjunction is pretty much like a masking of the two results. So basically, you have to have something that is significant in both to be significant in the conjunction. But you can also do like when you specify a conjunction in SPN, you can actually specify whether it is an inclusive or an exclusive conjunction. And inclusive means that whether you something is going to come up as significant in the conjunction when it's significant in both of the results, and an exclusive conjunction is going to give you something to be significant in the conjunction only if it's significant to the first but not to the second, not in the second. So in this case, we will want like an exclusive conjunction, so that is actually, it gives us some significant difference in the first test, the one that is comparing the contrast, the fourth contrast to the average of the second and the third, but it doesn't give you, it gives us a significant result in the last test that is actually comparing the second contrast to the third contrast. Does that make sense?
Yeah, and I've already run those sort of pairwise analyses, so just
cool. If you have them, we can look at those and actually.
Yeah, I didn't run them through SPM though to look at where they were different. I just ran them and then looked at the literal second level plots. So I'm not completely sure how to run it in SPM, but there's pretty extensive SPM documentation. So.
Right. So let's just look at the ones that you have then. And could you show us also the configuration file just to double check that everything looks fine?
Yes. Same phoneme, same syllable versus all different. Okay. As soon as this is done doing its thing. So this would be the second level, same phoneme, different syllable. Wouldn't be that useful, but like the same phoneme, all different, same phoneme, different syllable would be the one that I used to. Same phoneme, same syllable versus all different. Okay. So yeah, this would just be the same phoneme, same syllable minus baseline, and the all different syllables minus baseline. So I haven't pooled them yet.
Oh, that's fine. Okay, so you have that. This one is looking at the fourth contrast. Well, but it's looking at the opposite direction, right? Because you are looking at the contrast within of 1 minus 1. So you are trying to find whether there is higher activation in the the second contrast compared to the fourth contrast, right?
Yes.
Sorry.
Then this was, hold on, what's this? Which one did I open? Same phoneme, same syllable versus all different. Yeah. So it's thresholded out as of current. I don't know. If you just want to see what's there, you can.
That's fine. Could you just change the directionality to look at the negative directionality of the results?
No, not a lot.
And lower the thresholds because again, only 7 subjects, so we're going to be having to lower the thresholds for pretty much everything.
Sorry, what?
Lower the thresholds because with 7 subjects, there's not much.
Yeah. So.
So I think you'd want to lower the height threshold rather than the cluster.
Yeah, or yet more.
Yeah, right. So 0.01 something at the high threshold and remove completely the cluster threshold. So we actually see. So I just set a 1 for the clusters. Yeah, perfect.
That's 0.1. So
yeah,
that's
not much of an effect.
So
can you look at the left medial
Yes.
view? Yeah.
Back to make the height threshold 0.05. Wow. You go down this rabbit hole of what things can we look at, where they're and not considering what we are looking at. So this is all diff minus same phoneme.
Yes. So this is same phoneme, same syllable, and all different.
And we're looking at it all different.
Yeah. But I'm thinking about it now, and I should check to make sure that it's properly only looking at the second word, because if you're looking for repetition suppression, obviously you only care about the repetition. I need to check that it's not using both the first and the second word. I think it is. I just want to check that.
Yeah.
Right, that makes sense.
Yeah.
But yeah. The other thing just to point out is that when looking at these individual plots, we've like for very few subjects and for at least previous studies, there haven't been much consistency in individuals. So not having too many results with only 7 is pretty much to be expected right now.
Especially since at least 3 of those 7 have had like noticeable resections or other, things that don't seem to be causing any functional impairment, but might understandably result in different results if it's averaging over a part of the brain that is no longer there.
Yeah. Potentially. But what we see here is that there's potential suppression in like SMA and pre-SMA, those two areas in the medial, like superior medial areas. And then could you look at the left lateral again? Could you make it a inflated surface?
Yeah.
Yeah, and so potentially the far ventral areas, motor cortex.
Sorry, let me just check. And this is at 0.05, so.
If we wanted to go back to that, to try to tease apart, say, phoneme versus syllable representation, I guess all of them.
Right, we will want to actually do the comparison.
Like how we might want to do that, just in case, like, somebody would, if there's something else like the S-rate study, maybe you could give this a shot just to see what it looks like. So you could see, like, like set up the 2 or 3 different analyses such that you could pull from that some information about this and see if it matched that at a group level. Do you think that's worth doing?
Yeah, definitely. Yeah. For this is just comparing what we call the contrast 4 to the contrast 2, right?
Yes.
Yeah.
So we will want to also compare contrast 4 to contrast 3, and then compare contrast 3 to contrast 2 to actually discern whether this is like a pure phonemic or pure syllabic or something else, basically, in the region.
My concern with that, which since the statistics are so weak, it doesn't really matter. But my concern with that is that it's none of it's corrected then if you're just doing a series of comparisons.
Yeah, this is just
right. But
this is exploratory.
Right, and right. It's
exploratory. No, but all of these comparisons, when we do those 3 comparisons, what we actually do after that is going to be a conjunction of the 3. And when you do the conjunction analysis, it takes into account the potential correlation between the different analyses that you have and the fact that you have multiple analyses. So that is fine. That level of correction is fine. It's still not going to show us anything, most likely because the 7 subjects type of thing are having very low power in these results. But just for the practice, it might be good to actually do it. It's only there is a lot of work to do it manually. But you can actually do it. You can just set up those 3 individual analyses and then run a conjunction across the 3 analyses to actually see whether there is anything that corrected across the fact that you did those 3 comparisons behaves as you would expect it to behave if the region was purely phonemic, for example.
Okay. So just right now you want to do 2 more versions of this?
Sure.
Right, and I would change the direction of the contrast just so that we don't have to look at the negative results, so that we can focus on positive results. So basically, yeah, so that it follows what we would expect if the region was purely phonemic, right?
Yes. So I haven't run that one versus the all different. I ran the same phoneme, same syllable versus the same phoneme, different syllable. But I haven't run same phoneme, same syllable versus same phoneme, different syllable versus all different yet. So that would probably look something. So that would just be same phoneme, different syllable. Right? And then everything else should be the same.
Yes, exactly.
This is super fascinating for you guys, I know.
This is all practice. Practice is good.
Yeah. And in this case, we wouldn't necessarily expect anything in areas that show the difference between the syllable and phoneme, right? Because in our models, these are the same level for.
So for both of these comparisons, I think they would be. Oh no,
there was a gradiated option, right? Where no, there isn't.
Oh yeah. So no, I guess you're right. Sorry. So when you see difference, that might be either phoneme or difficulty, I guess. Right?
Yeah.
So regions that appear in both as significant in this direction could still be difficulty or phonemic, right? Because both of them are going to show up as condition 4 being higher than condition 2 and condition 4 being higher than condition 3. Mm-hmm. And then we'll have to actually test condition 2 and condition 3 against each other to basically tease apart whether this is a purely phonemic, that it shouldn't show any significant difference between those two conditions, or a purely difficulty where it should show like higher activation in condition 3 compared to condition 2.
Oops. All right. Oh, it's M&I space versus surface space.
Mm-hmm.
So it's, you can just project it. This is looking at a slightly different analysis because I ran it on the M&I space instead of the surface space.
But change the thresholds again. Yeah, cool.
Oh. Here's our Christmas tree. Hold on, maybe if I... So it seems to have the opposite effect. Just trying to get a look at the medial.
In the view, upper left view, and then left medial.
Oh, sorry.
And then, yeah, cool. So perhaps something to notice is the slight positive activation in SMA, actually. So a little bit further forward. There's like, no, I mean, it's very faint, but yeah, right there.
I did not even notice that.
That's this was all different minus same syllable.
This was same syllable minus syllable. Wait, no, it's all diff minus same syllable. We switched the contrast.
So if it was
same phonemes, different syllable.
Right. So if it was
minus same phonemes, different syllable. So if it was phoneme dependent, you would be seeing more dramatic results, which it does not appear to be. So this, again, I'm not drawing any conclusions from anything this underpowered, but hypothetically, given we saw some stuff in the other one and not in this one, it would imply something more like this.
Right, exactly. I mean, the knot in this is a difficult thing to make, because when you have a low power study, then you're going to have a bias to not see any significant differences, not because there aren't, just because you will only notice if there are huge differences. So it's a little tricky.
That was more in terms of practice drawing conclusions.
Yeah, in terms of practice, you're exactly right.
Actual conclusion.
Right. In terms of practice, that is exactly what you're getting. If you see a region that shows higher activation as you would expect between the fourth and second condition, but you don't see any higher activation between the fourth and the third, then that seems to indicate that it's either, that is likely the syllabic profile what is showing. You would still want to look at the comparison between the third and the second, just to make sure that that looks fine, but you would expect that to also be.
Okay, so we want these two, which I think have already been run, but let me check. Same phoneme, same, yeah. So second level, same phoneme, same syllable versus same phoneme, different syllable have already been run.
Can we just look at that config file?
It's a super long one. Yeah, so it'd be this one.
And
right, and the direction should probably be the opposite, right? Because we are, if this is a, yeah, exactly.
Although, unless I rerun it, the plot won't be.
Right.
Don't remember if it's in surface space or not. We'll find out. Oh, there's something there on the actual, like, reasonable threshold level. I mean, I don't have to, but just for the sake of comparing them on the same unfair plane. Whee! So there does seem to be a syllable effect.
So again, that would point to a syllabic type of region, right? You don't see. Oh no, we are. This analysis is comparing the third and the fourth contrast, or no, the second and the third.
The second and third.
The second and the third. So yeah.
And then let's go ahead and look at the medial. Yeah, you do.
Is it set to 2A?
So what?
Is it two-sided?
No. It's one-sided positive. Which, oh, we should be interested in the one-sided negative because this is before I flipped it. Oh, well, it just depends on which one you want on the top and which one you want on the bottom.
You don't want to see both directions? As in, I don't know. I'm just asking.
I mean, it depends on what you want to look for.
Yeah, I think in this case, we would probably just want to look at one direction because because that's the hypothesis that we have, is that it's only meaningful. So like for those models that Megan was showing, the only difference that's meaningful are ones where the contrast 3 is greater than contrast 2.
Yeah. So given how it's set up before we flipped it, it was same versus same difference. So it would show you areas where the same is bigger, so you would be interested in the negative contrast.
Which is
The
troubling.
less interesting one.
Troubling where that's showing up. Where
Yeah.
If you change you're repeating just the same thing over and over versus
Oh no.
changing it. But I mean, ultimately, this is what we found when we did a deeper dive into looking at this repetition suppression. Is it's pretty unwieldy.
No, there's also, I wouldn't be too discouraged at this point though, because of the number of subjects. And also, I mean, there's other reasons to be discouraged, but
There's always a reason to be discouraged.
But and it may depend on the way that you're, getting these, like specifying the when speech is occurring and things like that. So,
yeah. And I think right now it's just comparing the repetition blocks versus, the same block versus the same different block. I think we might get better results if we only looked at the second word, because the first word's washing it out, because the first word isn't repeated.
Right.
So that's, I think, my next step.
Right, and this is mostly for practice. And let me show you also how to do that conjunction in SPM, so that you know how to do that as well. Because now we've looked at the 3 individual contrasts, and from that you get a sense, but it's kind of like a visual sense. You're just judging visually whether something appears to be one way or another. So how would you actually run a significant test for the conjunction of several of these things?
Yeah.
So
just quickly rerunning that one so it's in the direction that we want. The last one that we looked at.
Sure.
It takes a second, right?
Mm-hmm.
Yeah.
Yeah.
yeah, actually, the way that SPM works, it likes to have all the contrasts in one analysis itself. So we're gonna we're gonna be basing the conjunction on the original analysis that so remember that original contrast that you showed me that was just looking like an omnibus type of test where there is any activation in any of the 3 conditions. We're gonna use that as the base for the conjunction, basically.
Equally discouraging.
Yep. I mean, it would be discouraging if it was less discouraging, because that would be lack of consistency. All right, so SPM conjunctions, those sound like fun.
Okay, so could you check or run the analysis? Let's do it on the volume level analysis, because it's going to be more meaningful in SPM, at least to look at. So could you run the analysis, the type of omnibus test? I don't remember the name of the config file. On the one that was looking at whether there was activation in any of the 3 conditions.
Oh yeah, I've already run that in volume space as well. I just didn't display it.
No, okay, so let's display that, basically, the results.
Okay.
You just run that recently, right? Not after you change the 6 contrast to 3 contrast type of thing.
Yeah, hold on.
Okay.
Oh. All right, what was the name of that one? Full speech. Average speech.
it may also be good to, if average speech is not necessarily like the most specific or
No.
yeah, so yeah, consider creating a new file to.
This was the first one I ran, hence the super general name, because it's like,
Yeah.
oh, I'm only going to be running one. This is the
Yeah, and I went for the rhythm study. I ended up changing a couple of names, just creating new config files with they're the same thing but different names, just because I realized that my conventions for naming things were not great the first time around.
Alfonso, I think in our last meeting we talked about adding like a label flag where we could have a more descriptive, like include more descriptive information about the model we're running. Is that
Right, that should be in there already. Could you, let's actually try it. Could you just click on the bar plot there to see whether you can actually, and just click OK on everything.
Ooh,
Ooh.
that's so pretty. Oh, I love the labels.
So that allows you to look at the 3 individual conditions for every of the individual cluster that showed up in this analysis. So these are the 6 groups are the 6 clusters, and the 3 bars are the 3 conditions that we are testing in this analysis. And you see the error bars are relatively huge, so that's why we are not getting anything very clear from that. But then,
yeah,
this is great. I love this. This is awesome.
I'm so happy.
Same phoneme,
same phoneme, same syllable minus baseline. Same phoneme, different syllable should be the green one, and then red is the all different.
Right. So this is like the 2nd, 3rd, and 4th contrast that we were talking about before, right? In that order.
So, just heading into this, you would think that in most areas you would see more activation in all diff than you would in the other ones.
Not necessarily. If it's insensitive to a specific pattern. So if it's like in previous studies, we found that there were the insensitive areas that didn't show syllable or phonemic representation.
Yeah.
And this would be it's sensitive to phoneme. Sorry, syllable would be if this again giant error bars doesn't mean anything, but.
Right, and these regions might be a little bit large because the regions, the 6 areas that is showing you are the 6 clusters that we're creating this analysis, so those might be a little bit excessively large for our purposes, basically. Could you go back to the original figure just to see where those clusters are? Well, they are not that large anyway. Well, that kind of like inferior. Or cerebral.
They're in areas that you would expect them to be some like active during speech and some differentially modulated, perhaps by the different speech tests. So that's interesting.
Like I said, I'm really interested to find out when you only look at the second word.
Well, so maybe Saul has this at his disposal. You guys can talk about this, but we looked into that with another data set, and it just was not. It's not as clear cut as you would think. But maybe with this is a different data set.
Yeah. I already have the timing information for the individual words, so it shouldn't be too hard to just
because there's
remove
a
a half
close in
of them.
time. Is that why it may not show a difference? Like it's in,
I mean, they're far enough apart. They're like almost 3 seconds apart where it should make
it's
some
not
difference.
like.
I mean, it.
And Megan, oh, sorry.
Yeah.
I was gonna say, remind me, are there 2 utterances total per trial?
Yes.
Just to repeat it. So,
well,
yes.
it might be repeated, it might not. That's the.
Right. Yeah, so I think there's a couple ways of doing this. That we've done this in the past, looking at the entire block, looking at just the second word. So I think it would be definitely worthwhile running that.
Mm-hmm.
There's another idea that I thought up that might also. So we were also at some point we were also comparing the second or the first minus second word to like directly get at like the amount of suppression.
Mm-hmm.
So that's also something you could look at. There's potentially, if you set another first level regressor that looked at the difference between the first word and the second word, basically just estimated the slope between the activations in the first and the second word,
Mm-hmm.
and then compared those slopes, that might also be a possibility. So there's a couple different ways that we can actually examine this. And I think because of the inconsistencies in previous studies, or just the so it's interesting. In previous studies, we had this 3 repetition thing where you'd be like bad, dab, bad, dab, bad, dab. And then we were trying to look at suppression across that entire block, which there might be some more complex response going on there. So this actually might be a simpler thing than in like past studies that we've actually we've had like full data sets for. So I think looking at each of these different possibilities, so looking at the whole block, looking at the second word, looking at the second minus the first, or the first minus the second word, are all potential ways that you could get at this representational response.
Yeah, so there's, lots of directions still to go with this.
Yeah.
So in the like the first, this is different than the other ones that we're looking at. And we just want to compare these direct comparison of compare the different conditions, sort of like in isolation.
Yeah.
But here so it might be worth discussing like what you would do with the design to get at the contrast that you to try to like what's the first trial. So should you have a condition that is first trial, non-repetitive?
Oh, and as opposed to just removing it from analysis, have that as a condition.
Right. Alfonso, do you have any input on that? Like, what would be the best? So if you wanted to do something where, I guess the simplest thing would just be to restrict the repetition suppression analysis to just the second item of a pair. Would it? And this is every 3 seconds, and it's event related, or is this a block? Is it this isn't continuous scanning, right? Is it one trial?
It's continuous scanning.
It's continuous scanning.
Yeah.
Right. I mean, I guess you could model them separately. I don't know if you are modeling separately currently or not, but if you are already, then you could just create like a contrast for the second repetition and a contrast for the first one, and then decide later at the second level analysis how do you want to combine them. Do you want to look at the difference between the two because that is going to be representative of the suppression that you're seeing? Do you want to look at the second alone itself because the first one might be have a little bit more noise or a little bit of other effects?
And I also think it would be important, and I'm planning on asking Frank at lab meeting tomorrow, if we figure out what we're actually using this data for, I think we'll have a better idea of what analyses we want to do.
Exactly.
So I'll bring that up at lab meeting tomorrow. You guys get to hear this explained all over again. Lucky you.
Okay, but just for the sake of practice, let's say that this analysis, again, this is just looking at a big omnibus test that is looking at every individual condition. So we actually want to test whether, do a conjunction of the controls, the 3 controls that we defined before, right? But we can actually do that within SPM to do the contrast. Don't close this, sorry. You actually need that window to get to SPM, no problem. I was just too slow.
Too slow to stop me. There are just so many windows. My desktop is so messy. It's very stressful.
Okay, so this is a little, a lot of manual work, but and I'll make sure that I have something in FL to do this conjunction a little bit simpler, because this is something that comes up very often. But right now you will click on the SPM, exactly, and then you will define the 3 contrasts that you care about here manually. So click on T contrast.
What?
And T contrast.
Oh, yeah. Right.
Right, and now define the contrast and enter there like a name. It's going to be, so you have to define 3 contrasts, the one that is comparing the second to the first, the one that is comparing the second to the third to the second, and the third to the first.
Oh, okay. Yeah, so it would be the same.
You like long names. I would have said 2 minus 1, 3 minus 1, 3 minus 2. Right?
Oh, and also another convention that we've used in the past is just initializing. So instead of same phoneme, different syllable, you would just do SP, D, or yeah. Exactly.
And now we're going to be sued by SPSS people because we are using a trademark.
Oh. Okay. So I have a name, and now
this contrast is across the three conditions that you specify. So that is going to be, I think if I got it right, there's going to be minus 1, 1, 0. Oh, you need to specify them separately. So you have to do first the SPSS versus SPDS, and then do the SPDS versus all diff, and then finally the SPSS versus all diff. And once you have those three contrasts, we're going to do a conjunction across all of those three.
oh, okay.
So it's even a little bit more tedious than you thought.
So then it should be -1, 1.
Exactly, yeah. 0 for the first, sorry.
Oh.
Yeah. Yep. You have to find, and now define a new one. It's going to be the SPD, all diff minus SPSS. Or AD, I don't know.
What's it? Same. Okay, so then that would be -1, 0, 1.
Exactly, perfect.
And then we now need same phoneme, different syllable versus all diff.
Exactly.
It's like a memory game. Okay.
Cool. And now just select the three of them, exactly. And now click on done, and it's going to ask you what to do with those. So we want a conjunction. Let me see. Wait for a second. Oops, sorry. Let me remember the three options that I told you. There was conjunction, null, and something else. What was it? The other one, intermediate, right? So yeah, the one that we wanted is called conjunction, because the SPM has this weird nomenclature that it has two types of conjunction. They call which type of null hypothesis you want to use, the conjunction null or the global null. The global null is more like an OR test, and it's not what we typically refer to as a conjunction, even though SPM does, while the conjunction null is the one that you want. So just to explain why we click on the conjunction button in there. And now apply masking none. This is none because we are not going to correct for whatever threshold you want.
Very loose.
And again, cluster level threshold.
Extent threshold voxels, is that just 1?
No, that's the number of voxels. Yeah, sure, is fine. Yeah, that's the minimal number of voxels in every cluster, and that's going to be.
Oh, okay.
Okay, so the results that you're seeing now in the SPM window a little bit further up is the results of the conjunction of those three contrasts, basically. And depending on, I don't know why it didn't ask us whether we want to use exclusive or inclusive conjunction. That's weird. I didn't see that question. Okay, so currently that is a conjunction of the three. So basically it's telling you whether there are any regions that would be like looking at what we call the difficulty, I think, pattern, right? That is higher in the second than the first, is higher in the third than the second, and is higher in the third than the first. So these would be the regions that actually show some sort of response that looks a little bit like the difficulty type of pattern that we expected. Does it make sense?
Mm-hmm.
Is there a straightforward way to look at one of the other ones?
Right. I was expecting for SPM to ask us whether we want to use inclusive or exclusive conjunction, but I didn't see that question, so I'm not 100% sure why it's not asking. It might be that it's only asking that when you have two contrasts. It doesn't allow you to do that for three contrasts. I'm not totally sure. I'll have to double check why it didn't come up, that question, because the typical, when you do this, typically SPM asks you whether you want to use either a exclusive or inclusive conjunction type of analysis to basically determine whether you want to include for the second contrast that you are specifying, whether you can actually want to include the regions that act significant or the regions that are not significant. I don't know. There might be another way to do the same thing. Let me think about it for a second.
For S-rate, I don't know if it's worth looking at this or not, but then when I was reading over it, though, that'd be kind of neat. But that would work for that, right? It's just like it just gets higher as you go. And,
right.
Sorry.
From fast up to clear.
Yeah.
Right. I'm not sure. I'll check the literature to make sure the SPM manual, basically to make sure that I'm well, to figure out what is it that I'm misremembering to where do you specify that information. But this is basically like the general way of specifying that conjunction. You enter the data into an analysis that has all of the data itself, and then you specify the different contrasts that you want to enter into your conjunction, and then just select all of them and just click OK, and that will run a conjunction analysis across the multiple contrasts that you specified.
Okay.
And I'll figure out where is it that you specify that whether you want some of this to be exclusive instead of inclusive conjunctions. It might be that SPM doesn't allow you to do a conjunction across exclusive conjunction. It only allows you to do exclusive masking as opposed to exclusive conjunction, which is pretty much the same, but it only allows you to use one contrast that you want to be negative. So I don't know. I'll take a look at the manual to figure out why is it that I didn't see that question that I was expecting, and tell you the next time the more explicit set of instructions for a general set of instructions for any type of weird conjunction that we might want to run.
Cool.
And again, in this particular analysis, we are not expecting to see anything because just, well, very low power for this type of analysis right now.
That's the theme of today.
Yeah, that's a little bit the thing of today, but at least just for the practice purposes, that's kind of like the idea. And some of the difficulties of this analysis, as Jason was saying, that I mean, this is fine when you have like specification of one particular a priori hypothesis, like one model, and that is already involved because you have to do a lot of comparisons and then do this type of conjunction to take all of those into account. So how do you even do that when you have like multiple models and you do a correction? So that's the whole motivation why the scripts that we created, the MBS, the model-based statistics type of analysis, were created to basically try to put all of these complexities into a more, well, easy and compact thing. So I mean, it's nice to be able to do this separately and to do at the voxel level this type of analysis because learning how to do those. But in practice, when we have these expectations that are basically multiple models and each model specify what is happening across multiple conditions, we tend to use we like to use the model-based statistics type of framework, which allow us to more easily kind of like get directly at which regions actually show a pattern that actually looks like what we would expect for this particular type of behavioral responses in a more direct manner and easier than having to do all of this manually.
Okay. Was there anything else that anyone else wanted to get at today?
I think if we're ready, it might be a good time to start talking about ROI-based analyses. If people are game.
Yeah.
Yeah.
Yeah, perfect. Any of you, I think Sol, did you get to run some ROI level analysis already?
I've run about 1 million of them, yeah.
So do you want to show us some of those to
Yes, I had to start up a new VGL session.
I have
so you had some question about the transit thing and
yeah.
Right. So you were trying to run transit from your computer and to run the FL pipeline on the SCC, right?
Yeah. So I mounted the SCC onto my computer, and so I can run all of the SCC scripts in MATLAB on my machine. But when I try to run FL, if it says that the SPM, it can't find the SPM version of SPM basically because it has a slightly different file path name.
I know this is the whole versioning. Yeah, so FL has this whole versioning thing just to make sure that we all use the same versions of SPM.
Right.
Because you know how MATLAB is. That people can have their own version. They could be running SPM5, and no one would be the wiser just because it's on your path in MATLAB.
Right.
And then it will make it a very confusing scenario. So FL forces us to all use the same software basically, and the way it does it is by making sure that we are all running the same thing that is actually on the cluster, and it's trying to look for that version and it's switching you to use that version. So that's why you're getting
right.
that. I think the simpler like a workaround for that is just copy FL, the software itself, basically to your computer locally. So have a copy of FL folder, the one that is in project software FL. And you probably also will need the one that is in IFLab 17. So the one that is in project software IFLab 17. Those two folders and the SPM as well. Yeah.
Yes.
Okay. So if you have those three packages in your computer locally and you run them locally, everything is going to work fine. You just need to specify that you want to direct that your data is going to be on the cluster, but the software is going to be locally on your computer. And the way to specify where the data is using this command that is called FL routes, I think. Let me just check. So
maybe, oh, sorry.
So there is it. So just run this command. So basically, once you have all of the software in your computer, you run FL root and then the folder where the root folder for the data on the cluster. So however you direct it to, so it will be called something like volumes. I don't recall the transit naming convention. It's
volumes and then the
SEC probably, right?
Yeah.
So it's going to be volumes, SEC1, project, MB, BUSP lab, and FL, capital FL, I think.
And and it expects that SPM and con to be in the same.
Right. So right. Once you have the FL. IFLab, con, and well, you could even change it. Once you have FL, let me check. Once you have FL on your, let me check quickly. I don't remember if the configuration files for they are all. Yeah.
Why don't we? For now, just run it on the SEC, and then we can, because this, I mean,
right. For today we can run it on SEC, but just in general, just make sure that the software. The idea is that generally the software needs to be on your computer locally, so that it doesn't try to use the version, so that you can actually change whatever versioning things you accept, have FL accept to be the ones on your computer, and then the data can be remotely in any like volumes, whatever, like a network drive the data is actually in.
Gotcha. Okay, that makes sense. All right. Well, so I've started a new session on using the VGL. So let me pull that up.
I was just wondering if, just before we get to the results, if we could just quickly open up the FL documentation and just walk through how you specify them, because I just had a few questions about if you're specifying multiple ROIs, or if you want to specify an ROI from like an atlas that has multiple indices.
Yep.
Right, that's a good
just
point.
that it's kind of like, the pre-step to results.
Right. Do you have the documentation around to show?
Yeah, I can pull that up.
Yeah.
So let me share my screen. So oops. All right. So all right. So the way that I did this, and I believe the way that it should be done, or like the way that it's supposed to be done, is basically in the same way that you'd have everything the same as for a second level analysis, but you would specify this ROI file. And so the ROI file that I used were these SL, FS average, either annotation files for the surface, and then other nifty files would work too. And that has a definition for all of the ROIs in that one file.
Excellent. Yeah, and that should work basically. That's the as long as you have to kind of like manually, there is no many internal checks that check for this, but you have to actually make sure that the ROIs that you're specifying are actually in the same space as the analysis that you are running. So if you are running M&I based, if you are running using M&I based results, make sure that your ROIs are defined in ROI in M&I space. And if you are running the results on surface level data on ROI. ROI analysis on surface level results, just make sure that your ROIs are defined also on the surface level, which means in FS average space, basically.
Yeah.
So then just one add-on question here. So if you were using like an atlas, like a probabilistic atlas file, which has a number of different regions, but you may not want to include all of the regions in the analysis, is there a way of specifying like, indices 4 and 6?
Right, that is a good question. It depends on how your data, I mean, currently there is not, I can add it. Well, is the data like a probabilistic atlas where you have like a 4-dimensional file, or is it like a single 3-dimensional file with individual index numbers for the different regions for every voxel?
I would need to look again at the format. Jason, do you remember the probabilistic atlas file that we have, if it's 4-dimensional or 1-dimensional? I think it's 4. It would make more sense.
I think we just have.
Right.
Well,
Does every voxel have a label?
So we have it a couple different ways. So
right.
We usually have we have one that's every voxel has a label.
Yeah.
So that's just be 1 volume, 3D volume. We for the subcortical stuff, we could do something where we have 4-dimensional, where it's just every volume is just it's a 1. We could do it where it's 1 or 0, or we could do something like what Alfonso talked about, where it's we can, if we want to add some sort of weighting, we can do it either way.
Right. So I mean, currently the way that you will have to do is basically create a different ROI atlas with the ones that you want, but that is kind of like tedious. So I haven't done this yet. I think we discussed this earlier, but because I have a note in here saying that I was going to add that, but I haven't done that yet. So basically, I'm going to add some option to, I'm not exactly sure where to specify it as a last argument to FL or something like that, where you actually can specify the different ROI names that you want for when you want to select a subset from a particular ROI atlas. Can you think of a format that it makes most sense to specify this list of ROI names? It should be like a last argument to the FL call, or should be like a structure instead of a file name for the ROI atlas file, or any preferences?
What did we? Yeah. I remember we discussed this. I can't remember. You had a suggestion that I can't remember what it was, but it sounded good at the time.
Today I have a cold, so my mind is not. I'm not going to be able to replicate any good ideas that I might have come up in the past. I can think about it at some point, but yeah. I mean, if you have any suggestions, let me know, or if you have any ideas. Otherwise, I think probably just add like an additional parameter with a list of ROI names that you might want to include within the ROI file. I still have to come up with. I mean, there are some other scenarios that the code is still not considering. What if you want to specify like multiple files? How do you specify that? Currently, you can specify multiple files, but you cannot specify like subject-specific ROIs. So I have to add that option still into the code. And also we wanted to add that weighting option, right, to have the possibility of use ROIs that is actually, sorry, go ahead.
That might be less priority.
I mean, I think that is a really cool idea, but we could hold off on that one.
Right. Okay, so ROI names, highest priority.
Yeah.
Yeah, I mean, if you need to run the analysis right now, basically before me actually doing this, just create a different atlas file. And there is one way you can actually run the command. It's called rex, the MATLAB thing. You call rex split and then the name of your ROI file. It will create a different ROI file for every individual sub-region that you have defined in the atlas. So if you have an atlas with 100 regions and you call rex split and the name of the original file, it will create 100 new files with each of those being individual ROI files for every individual region defined in that file. And then you can just manually merge whatever you need subset of regions or enter the list of subset of regions explicitly as a last argument to FL to run the analysis only of those subset of regions as opposed to all of them. Does that make sense? But it's a little bit tedious because you have to create all of these 100 files that then you don't care about. So I'll make sure that you have the option to specify those ROI names, and it will be a little bit more straightforward to do. But if you need to run the analysis right away and you don't want to wait for me, do that. That is going to be relatively simple to do.
Okay, that sounds good. Just one other potential issue that had come up before that we hadn't addressed was whether or not we would need to run a separate like pre-processing stream before doing ROI analysis, so that the smoothing is only done within the ROI and not across the whole brain, and then for you to pick out the ROI.
So this is actually something that it's actually quite easy to do the first level analysis, to change it at that level when you have to make no smoothing.
Okay.
Had we discussed whether to smooth within the ROI or just, I feel like the smoothing within the ROI is sort of redundant if you're doing the ROI analysis, because you're just taking the average across all the vertices in the ROI anyway.
Right. Right, we discussed at some point smoothing within gray matter regions, but that has its pros and cons, and that's a little bit, I mean, that's different. That's when you want to do like voxel-based analysis, but you want to still get the advantage of the surface level analysis that actually has some information about where cortical areas are as opposed to white matter regions and things like that. But from when you have ROI analysis, you typically don't want to smooth at all, because you're then going to aggregate across all the voxels within the ROI, and you don't want to basically smooth over the boundaries of those ROIs. You might have gone through the work of actually manually delineating those regions. They are exactly where you want them to be, so you don't want to, just because you are actually smoothing the functional data, to effectively end up basically blurring those boundaries. So for that, you typically want to run the first level analysis using unsmooth data, and the first level, as Saul was saying, the first level analysis are relatively fast, so you could just select there the option that run a specific set. You don't need to rerun preprocessing. You just need to rerun a first level analysis that actually specifies no smoothing at all, and then base your second level ROI level analysis on those unsmooth first level results.
Right, that makes sense. Actually, I think I might have got it mixed up with when we're using like the full subcortical mask, and then I think it's that we were saying that we might just only want to smooth within the mask and not, so that you're not blurring at the edges, or that you're not getting like the cortical activation bleeding into the subcortex.
Right, I see what you mean. Right, when we're doing the surface level, the subcortical stuff, whether you want to use that constraint smoothing or not to be able to do, that makes sense. And actually, we talk about this a little bit, and it was the whole thing about the insula, well, I mean, that is going to bleed into subcortical areas, that when we do subcortical level analysis, how to avoid that from happening. I mean, that's something to try it out. I think we could try out the constraint smoothing preprocessing step, and just to see whether we get anything different, basically, from cortical level analysis when you do that type of constraint smoothing, as opposed to no smoothing at all, or just regular smoothing.
Yeah.
So when going back to the ROI analysis for, so here's what that first level that I was running for the surface-based analysis, and you specify in there smoothing level 2, and then I just ran everything through a first level analysis that had smoothing level 0.
Yep, that sounds perfect.
And let's see. For some reason, whenever I log in, for some reason, MATLAB is no longer remembering my commands between sessions. I'm not sure why. But let's see. So would it be helpful now to look at just what the command looks like when I run this?
Yeah, I think so.
Okay. Surface space and speech. Actually, I need to go in the next couple of minutes because I need to do something, and then I need to be on campus before the scanning session, unfortunately. But let me just get this here. It's called this thing. And then let's do and then, oh, right, now I need to get that file again. I'm going to do my non-cool, non-codey point and click everything.
It's okay. Jason left, so he's not here to judge you.
Yeah, I saw that, so good. So Jason recommended for doing the surface analysis, for using surface ROIs, having the SLFS average .note, the annotation file.
Right, perfect. I think that's the latest version of the file.
And so then I'll just LH that. And I noticed that even when I just specified the left hemisphere one, it got
right. It's fine. It uses both. This is just like a simplification. You specify the left, but it looks for the right as well if it exists, and it will actually run the analysis on both.
So then this is my command. Is just putting in the path to that file.
Perfect. So yeah, in general, it's just like this, exactly the same as you would run a typical second level analysis, only that you add the path to the atlas file that you want to use for the ROI level analysis. And it actually needs to have the second level analysis actually being run before, because this is not rerunning those analyses, just using the results from the second level analysis that you just ran to actually extract the data at the level of the ROIs and then run ROI specific analysis within those regions.
Oh, and I should say that, so to actually get the results, I would type in second level .ROI.
Right.
But to actually run the analysis, I found that even if I left the file name for the left that in there, it would run it as if it weren't there.
It doesn't complain. Okay.
It doesn't complain. So I've actually been doing that, just running it with it there. Oh, oops! I need to.
Is my vision going? Oh, no.
Oh, is it just very small for you?
Oh, no, I can see it on my computer. It's just the projector's a little out of focus.
Oh, yeah. All right. So I would run this. And I think the file doesn't actually need to be there, the like file name. But then just to have it there, and then I run .ROI. And then what pops up is this Rex window. So then each of the ROIs, you can see each of the ROIs on this plot. And then each individual ROI is listed here. So you have like ventral somatosensory cortex, ventral motor cortex, and then specifies right or left hemisphere. And then for each of those, you get the beta value, your T value, and then your P value uncorrected, and then your FDR corrected P value, which I believe is across all the ROIs that you specify.
Yeah, exactly. And that's the reason why sometimes you want to specify a subset of ROIs, because if you specify too many ROIs and you really don't care about those additional ROIs, it's just because they were already in your atlas file, then you're penalizing your FDR correction because it's trying to correct across that many ROIs that you enter into the analysis. So you typically want to specify the ROIs that you want to enter into your hypothesis, basically testing, and only those without being it's a trade-off between being like overly conservative and only including the ones that you think is going to happen something, and including adding the risk of missing some other stuff that you weren't expecting, or including too many stuff and then actually missing the things that you were expecting because you are just penalizing a very heavy multiple comparison correction for all of those additional things.
And then the other things that we see here is the individual estimates for each subject. So like subject 1 has for this ROI, and changes for each ROI, this subject has a beta value of like 1.8, this one like 1.5, and this is all the subjects included. And then down here, so normally this is supposed to be, this is supposed to show the ROI like in the glass brain, but because this is a surface ROI, it's in this weird like.
Yeah, sorry about that. I'll fix that. But yeah, right. That's the Rex just not knowing basically what a surface ROI looks like in space. Basically, or at least not able to display that properly. So I'll fix that.
Yeah. And so then you just get, for every ROI you have, this the estimate, the t value, and the statistics.
Right, and you can also click on the figure on the bars that you think that they are significant, just to figure out which ones they are. And the results at the bottom, they are sorted by significance, so they are
right. Yep. So then to do this so then I did this because I'd already found, obviously for speech minus baseline, there's a lot of really significant results. It's not going to show too much. Just to run maybe 1 or 2 other analyses. I know for the group comparison, well, let me just look at the main effective condition. So rhythm minus normal. And I want motion aggressor in there too. Right.
So Saul, with this first command, you're just running the second level model, and then with the second command, is the ROI results, or?
Right. The first command is generally not needed, right? As long as you've already run those second level analysis. So I assume that you're just doing it just to make sure that you've already run the latest version of that second level analysis that you have specified.
Yes, and in addition to, because the first level analysis was different than the vertex-wise, or because we had smoothed the data for the vertex-wise analysis, you had to redo the analysis with a no smooth first level.
Right. And you want to make sure that all of the second level analysis that you are looking at actually have been rerun with the data.
Got it.
You could have also specified like a different first level analysis name, basically, or ID or code, basically, for the unsmooth results, right? So instead of just speech, call it speech unsmooth or something like that. So that then you would still have both as different set of first level analysis, so you can enter those, whichever you want, into your second level analysis stuff.
Exactly. Yeah. So then you look at this contrast, the ROI analysis. Then we find that, so we can look at each of these individual ROIs. And this is where, so normally the reason, well, there's a couple of reasons we could do the ROI analysis. One of them is in order to test specific hypotheses. And if you have like just one specific ROI, then I think you could probably just take the uncorrected version as long as you had it very a priori. But if you were doing an ROI analysis that covered multiple ROIs, then I'm guessing it would make sense to use the FDR corrected.
Yeah, exactly.
Sticks. So looks like there's a whole bunch of ROIs that are statistically significant. uncorrected, and they mostly match up with what we found in the surface-based analysis, but then just restricting that to FDR corrected less than 0.05. We see similar but not exactly the same results in it. So one thing that I found was that so the left planum temporal, left SPL, superior parietal lobule, and left SMA were also found in the surface-based results. But we didn't actually find a cluster in ventral premotor cortex or ventral inferior frontal pars opercularis. That's right. And that's right hemisphere either way, but we didn't find that either. So perhaps one thing that will be important to clarify at the lab meeting will be how exactly we want to use the ROI analyses. Versus,
right. And also, I mean, in our next meeting in here, we could also talk about it. I mean, it would be nice to look at the results both for the next week, basically. But we can look at the results basically of voxel level or surface level analysis and ROI level analysis, and then we can compare what is it that you see in one and another, and talk a little bit about the difference in sensitivity. And I mean, all of this kind of like makes sense based on typically should make sense, at least in terms of the sensitivity of the different type of analysis to different type of effects, right? Because So, but we can talk about that in more detail in our next meeting, basically. But it would be nice to basically be able to compare them visually in a couple of examples just to show, I mean, which cases do you actually see more results or more stuff if you do ROI level analysis, and in which cases you don't actually. Some cases you actually see the opposite, and you see some results in voxel level analysis don't quite appear in ROI level analysis. So we can talk about that as well.
Yeah. So I need to go. Just so I can be on campus for the scan a little bit later. So I'm gonna.
Well, thank you very much, and good luck with that.
Thanks. All right.
Do you have any specific? The rest of you, do you have any specific questions that you would like to talk about this, or should we just reconvene for our next meeting and continue talking about ROI level stuff?
I think we can just reconvene if that works for everyone.
Perfect.
Do we want to set a time for the next meeting?
Yeah, actually, I'm going to be. Let me see.
Oh, you're coming to Boston.
Yeah, right. This Friday, I'm going to be there as well. So next week is going to be the crazy Contoolbox workshop week. So I'm going to be doing my disappearing act. So that's going to be hard. So it's either tomorrow or Thursday, or just leave it to the week after the next, basically. Those are kind of like the only options.
Yep.
Because Friday I'm traveling itself, so.
I don't know. I don't have a strong preference.
I don't have a strong preference either. I feel like
I'm happy to leave it to the following week.
I was going to suggest that as well, especially since no one else can weigh in because we're the only ones here.
Sounds good, and that will give me plenty of time to actually run this additional, include those additional things that we want into the ROI level stuff. So we'll have more things to talk about. I can in those results as well.
So potentially we could say that Tuesday morning again, like around the same time.
Yeah, sounds perfect to me.
Okay.
Check calendar.
I'll send out an email and then see what people. I'll tell them that's the time, and if they complain, we can.
Sounds perfect. Yeah, I don't have anything on that, so that would be like the 7th, right? May 7th, Tuesday morning.
Yeah.
Perfect.